Imagine you have an image of a dog before you. How can you tell if a dog exists in that image? So you're able to tell because of the way the brain is structured. The brain has got neurons as well as connections. So here, let's imagine that this is a simplified version of the human brain at this bottom left corner. So here, instead of having 86 billion neurons, we only have 3 neurons, neuron N1, neuron N2, and then neuron N3. And then you also have connections. So a connection exists between neuron N1 and N3, and then there's a connection between neuron N2 and neuron N3. So we have W1 connection, you also have W2 connection. So these are weights. So W1 and W2 can also be referred to as weights. So these connections can be stronger or weaker depending on your experience. So let's imagine that you have experience driving a manual car. So you have experience driving a manual car, and then you've learned that over the years, and then you've done that repeatedly. And for that reason, your W1 and W2 for that task will be strengthened. So they go very strong. And because W1 and W2 are strengthened, you can drive a manual car effortlessly. Why? Because you already have experience, you've done that repeatedly, and then the neurons, the weights in your brain are fine-tuned and such that you're able to drive effortlessly. So, however, if you are presented with an automatic car, and because you do not have experience driving an automatic car, you have not learned that, you've not done that repeatedly, then that means the weights in your brain, in this case W1 and W2, are not fine-tuned. So they are weak, and for that reason, you would struggle to drive an automatic car. The same thing applies to a toddler. A toddler has not seen a dog before. The toddler will struggle to identify a dog. And then let that toddler have experience and then has also learned, through images of dogs. And then say after 6 months, W1, W2 would have been strengthened. And for that reason, the toddler would be able to identify a dog. I hope this example makes sense. So here we can see the human sees a dog, and that image goes through the eyes, through the optic nerve to the brain, and that image would also interface with the W's in the brain. And then the system would then classify that image is a dog in this case. So the same thing applies here too. You have your neural network, and then your neural network takes in an image, and that image would also interface with the W's in the neural network, for example, W1 and W2. And after the interaction, your system would also spit out an output, in this case, a dog. And then you have a neural network here. So just like the example I gave, in this case now we have input. So instead of having an image, you have input. So we have X1 and then X2. So this could be numerical values too. So maybe this could be temperature, or this could be a pressure and all that. Yeah, so you have an input. So X1 goes into the neural network as well as X2, and X1 and X2 would interface with W1 and W2 to give an output. And you can see the output here. So in this case, you can see you have X1 times W1 plus X2 times W2, and that would give an output. So during the training process, W1 and W2 will be strengthened such that the output will reflect, the reality. I hope this example makes sense. So let's go to our Google Collaborate, and in our Google Collaborate, would implement this one. We'll use our numpy to create our input data. We'll also use our numpy to also create our weights, and then we'll do a numpy multiplication, matrix multiplication. Okay, so let's go to our Google Collaborate, and then, so we're here, and then we would click on our folder, and from our folder, we would also create a file, and then we can name that file lecture 5, lecture 5, lecture 5, and then the first thing we'll do is to import our numpy array as np, and then we would want to create our input, isn't it? So we have x1 and x2. X2 will look like this. So x2 will look like this. numpy.array. Remember we did this, we treated this in the last class. So we would have, say we have 2, and then 3. So let's try and get the shape of this. So we could come here to say we'll print the shape of x1. We don't need this one. So then run it. Oh, I need to put the shape there. I want to get the shape. Here you can see, so that's the output. You can also print, let's print the shape and also the content. So you can see, so we have 2, 3, and it's a 2 by 3 array. And what that means is we have, remember, our shoe rack. So what it means is that we have a shoe rack. So this is x1, and this is x2. Our shoe rack has got 2 rows. Remember, this is row 1 with index 0, and this is row 2. No, sorry. Yeah, row 2 with index 1. And this is column 1. Let's take that. That's this column 1 with index 0. So here we have 2, and then we have 3. I hope this is clear. So that's what we have here now. So that's our input, 2 and 3, just like we have in R. So that's our input. So we are modeling our input. And then the next thing is also to have our weights too. So W1 and W2. Create this numpy array, and then would have, let's say we have 1 and 2. So just have 1 and 2. So let's take this out. And then 1, 2. So remember earlier, this is the first row, and that's the second row. So you can see there's a box here. There's also a box here. That suggests this is a row, and that's a row. But if you look at this one, you can see the box encapsulates 1 and 2, meaning we just have 1 row and 1 row, 2 columns. But here we have 2 rows. This is the first row. This is the second row, and then 1 column, just like you see now. 2 rows and a column. But here now you can see now this box encapsulates 1 and 2, meaning 1 row, 2 columns. So let's find the shape of this. We'll do the same thing here. And then let's print this one. Just print to divide. So we have this, and then we can replace this one. So you can see the first data, which is x1, our input, has got two rows and one column, whereas this one has got one row and two columns. So this is how it looks like here now. So we have this one that looks like this. So this is our W1 and W2. And then in W1 we have 1. Then here we have 2. So this is x1. So W1 would multiply x1, and W2 will multiply x2. So our output would be what? Will be W1. So W1 times x1, which is 2, plus 2 plus W2 times x2, that is 2 times 3, that is 6. So our output is what? 8. So let's see if we have that here. So it becomes, use our output is equals to, so that is numpy dot, and then we have this one, weight, and then we'll have our input. Let's take this out, and then we can print our output. So let's do a divider here, and then we can print our output here. So print this output, and let's see what output would look like. So you can see it gives 8. So let's see if we're correct. We're correct. So you can see that gives 8. And so from this now, so the prediction could be maybe water level in millimeters. So here we got 8. So it could also be, water level as an example. So this gives 8. So you can also write this. So what I would put this on my YouTube channel. I mean this code. So you can also copy the code there and run it yourself. So you can also change the numbers here. So imagine you have 6, and then you have 3. So what do the output look like? You can see that you can see that gives 12. You can also try to adjust the weight. So the weight, you have 81 over there. And then let's see if that will work. So you can change the parameters, the numbers, and see what you would get. So thank you very much. I would see you in the next class.